Petrol is a fuel used in some car engines. Thanks for telling us. State what is meant by the term fuel. Well, fuel, you should just learn this as one of your definitions in National 5 chemistry, a substance that is burned to release energy, or a substance that is combusted to release energy. Okay, that's what a fuel is. Not all of them are organic substances. What you mustn't do here is put in an example. You can't put petrol in as a fuel. You can't say petrol, and you can't give examples here. You got to define what the term fuel means. So you put in an example, you say petrol or gas or coal, you'll get marked wrong for that. That's the common trap here. So, students put in examples rather than answer the question. Okay, here's a structure we have to draw. Systematic name for isooctane. This is not the way we normally name things. It's showing you that there's some old-fashioned words that are used in chemistry still, but the systematic name is 2,2,4-trimethylpentane. We have to draw a structure for isooctane. So the first thing you have to figure out in this question is that you're being asked to recognize that isooctane is the same as 2,2,4-trimethylpentane. We don't know what isooctane is because we haven't really learned about it. You probably haven't learned about it anyway in your studies. It's not part of the National 5 curriculum. But it's this stuff, and we have to be able to draw this. This we do have to learn in our National 5. So I just thought I'd leave the gap here and draw it live in the question, just to go through the process because it's good revision. What we do really is we start off at the back end of the name. So we start off with pentane. We have to draw 5 carbons. So I'm just going to draw 1, 2, 3, 4, 5 carbons. It's a pentane, so they're all single bonds. Okay, there's no enes or anything in there. Now, what have I got? I've got 3 methyl groups, and 2 of them are attached to carbon 2, and 1 of them is attached to carbon 4. So I'm going to have a methyl group there, and a methyl group there. I'm not going to have much space here, so I have to put in my hydrogen, and my hydrogen, and my hydrogen up there. It's quite difficult to draw these fully, and I'm going to put my hydrogen there, my hydrogen there, and my hydrogen there, and then I've got one on number 4, 1, 2, 3, 4, and I've got my other one there. There's a bit more space here. Okay, and then I have to fill in the rest of the hydrogens. Every carbon must be attached to 4, it must have 4 single bonds coming off it, and if it hasn't got a carbon on it, it has to have a hydrogen, right? So just make sure you do your accounting at the end. That carbon, yep, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and we need 3 hydrogens here. 1, 2, 3. And that's okay. So one trap here in this question, of course, is that if you get confused by this word octane and you see octane in here and you think that you have to draw 8 carbons across here, and you're going to get all confused about the structure. So you might make a mess of it the first time, the second time. Go back, go and use the space at the end of the book, and then put an asterisk in to say answer at end, and put the number and the part of the question that you're answering at the end of the book. But you don't have a single 8 carbon chain. The old naming method meant that we had 1, 2, 3, 4, 5, 6, 7, 8 carbons in total, even though some of them are branched off. The new naming method just goes for pentane as the base molecule with the 3 carbons coming off as branches. It's methyl groups. Okay, isooctane is produced. This is this stuff again. They're still on about it. Isooctane is produced by reacting together isobutane and isobutene. State the test, including the result, that could be used to distinguish between a sample of isobutane and a sample of isobutene. Right? So you can forget all that. All you have to do is spot one thing. And this has a double bond in it. This is an unsaturated hydrocarbon. Is it a hydrocarbon? Yes, it is. And this is a saturated hydrocarbon. So if I shake this with bromine water, nothing will happen because there's no bonds to break here and incorporate the bromine and remove the bromine from the bromine solution. Whereas here, if I shake this with bromine water, it will break these double bonds, and the bromine will attach to the molecule. The molecule itself is colourless, but what it basically does is it removes the colour from the bromine water because the bromine's slightly brown, right? Red-brown. Now, what you have to do here is try and figure out the simplest way of saying that without getting into trouble because there's a couple of experiments there. Just concentrate on one side. So we can say what happens to the isobutene, or we can say what happens to the isobutane. We can do either of those. So isobutane will not decolorize bromine water, or isobutene will decolorize bromine water or bromine solution. Generally, chemists call it bromine water, but it is technically, I suppose, if you're going to be correct about a bromine solution. We have to do a bit of work in this table, and what I did is I introduced a column for carbon number and a column for branches, okay? So I just labeled them C and B. Hexane has 6 carbons. Trimethyl, 3-methyl pentane, so 5 plus 3 is 8. Heptane is 7. Dimethyl hexane, so 2 plus 6 is 8. Methyl heptane, 1 plus 7 is 8, and octane is 8. Okay, good. The branches are 0 branches in hexane, 3 branches in trimethyl pentane, 2 branches in dimethyl hexane, and 1 branch in methyl heptane. Okay, so now we have the number of branches and we have the number of carbon atoms, and we just use those data. We can ignore octane because there's no branches. We could theoretically add octane in because it's got 8 carbons, right? So start from 0 branches to 1 branch goes to 4, 13 to 4, to 2 branches with 8 carbons is minus 3, and then 3 branches with 8 carbons is minus 12. So what we can see is that as the number of branches increases, the flashpoint temperature decreases, okay? And that's our little statement for relationships, right? So as the number of branches increases, the flashpoint temperature decreases. And that's what you have to do there. There's a lot of work involved in that one. And we're not finished yet with this question, so let's have a look. Predict the flashpoint in degrees Celsius of the alkane shown. Okay, well, what have I got here? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. I wrote 9 down here, so save me counting it again, right? Always do that in your exam. If you've done a bit of work, write down the notes so that you don't have to do the work again. Save yourself some time. Okay, so what I've done here is I've taken, this is a straight chain, no branches. So I've taken the other information for no branch chains. So 6 is hexane. Hexane is minus 22. I put that into my little table. Again, I drew a little table. 7 is a straight chain, minus 4. And 8, straight chain, 13 degrees Celsius are our flashpoint. So let's look at the table. What's the trend? Let's look for the trend in the table. So minus 22 to minus 4 is plus 18 degrees. Minus 4 to minus 13, minus 4 to plus 13 is plus 17 degrees. So 6 carbons to 7 carbons, the increase is plus 18. 7 carbons to 8 carbons, the increase is plus 17. 8 carbons to 9 carbons, the increase could be what? It could be 16, because that's the trend, 18, 17, 16. It could be the average of this. It could be 17.5. Could just be another 17. Maybe it could be an 18. Okay, so it's going to be somewhere between 16 and 18. 18 might be pushing it. That's going against the trend. It's going up. So I'm going to stick with 16, I think, because I like the trend 18, 17, 16. 16 plus 13 is 29 degrees. So I went for that. In the answer scheme, they allowed you to go for anywhere between 29 degrees, I thought that was my smallest, all the way up to 31 degrees, which would be the 18. So any of those numbers that you work out will work for the answer. Okay, good. So alcohols are commonly added to petrol to help them burn. These compounds are often described as oxygenates, right? The clue might be in the name here. Suggest why oxygenates help burn petrol. Well, what do you need to burn things? You need oxygen. So they contain oxygen. And alcohols, because they have OH groups, and sometimes they've got more than one hydroxyl group, they add a lot of oxygen. So they contain oxygen. All right? The alcohols commonly added to petrol are methanol and ethanol. The boiling points of methanol and ethanol are shown. Methanol 65, ethanol 78. Explain why ethanol is a higher boiling point than methanol. Okay, and what we learned is that the higher the boiling point, the stronger the intermolecular forces. Okay, also larger molecules have higher boiling points as well. So as we go up the alkanes, for example, from 1 carbon to 8 carbons, we get higher boiling points. But That is also because of their intermolecular forces. So in general, what we want to say is ethanol has stronger intermolecular forces, or you could say methanol has weaker intermolecular forces, but you'd have to qualify that because you're being asked about ethanol, right? So if you said methanol, if you're going to say methanol has weaker intermolecular forces, you would have to say thus a lower boiling point than ethanol. Okay, you'd have to qualify that a wee bit extra, I think. And you can actually, because you're being asked why ethanol is the subject of this question, you can use it here, and that would refer to ethanol. You can't say it has stronger intermolecular forces. That will get you the marks as well.